Have you ever stood on the ground and just felt solid, safe? Well, what if I told you that just a few miles beneath your feet lies an ocean, not of water but of scorching hot, flowing rock, an invisible ocean, thousands of miles deep, constantly churning in super slow motion. It's called the Earth's mantle, and it's the engine of our planet, driving everything from earthquakes to the creation of mountains. But here's the crazy part. Parts of this incredible rock ocean are vanishing, disappearing without a trace, and today we're going on a geological detective mission to find out where it went. Let's start with the basics. Picture the Earth like a giant peach. We live on the thin skin, the crust. In the middle is the pit, the core, and everything in between. That massive, juicy part is the mantle. It makes up about 84% of our planet's volume. Now, when we say ocean of rock, don't imagine a liquid like water. Think of something like super thick, ultra-hot honey, or silly putty. It's technically a solid, but over millions of years it flows and convects. Hotter rock from deep down rises, cools near the surface, and then sinks again. This process, called convection, is the heartbeat of our planet. It moves the tectonic plates that our continents ride on, shaping the world as we know it. This slow, predictable dance is what geologists have understood for decades. It's the foundation of modern geology. But the Earth, as always, is full of surprises. And recently, scientists have been staring at their data, scratching their heads, and asking one simple, baffling question. Where did the mantle go? The mystery begins in some very specific and frankly weird places on Earth. Take the area beneath the western United States, for instance. Using a technique called seismic tomography, which is like a CAT scan for the planet, scientists can map out the mantle. They send seismic waves from earthquakes through the Earth and measure how they travel. Just like light bends when it goes through water, these waves change speed depending on the temperature and density of the rock they pass through. Colder, denser rock speeds them up, while hotter, less dense rock slows them down. For years, scientists expected to see a thick, continuous slab of mantle beneath the North American continent. But in a region stretching from California to the Rockies, the picture is patchy. There are huge chunks of the upper mantle that are just gone. It's as if a giant cosmic ice cream scoop came down and carved out a massive piece of our planet's interior. We're talking about a volume of rock larger than the entire Sierra Nevada mountain range, mysteriously absent. And it's not just there. Similar anomalies have been found under the Mediterranean Sea and parts of East Asia. The textbook model of a slow, uniform mantle just doesn't explain this. It's a geological cold case, and the clues are buried 100 miles deep. So, where could something so enormous disappear to? The leading theory sounds like something out of a sci-fi movie: mantle dripping. Imagine a thick layer of honey spread on a piece of toast. If you leave a particularly heavy dollop in one spot, what happens? It slowly stretches downwards and eventually drips off. Geologists believe something similar is happening inside the Earth. The base of the tectonic plates, the part that touches the hot flowing mantle, is called the lithosphere. Over millions of years, certain parts of this lithosphere can become colder and denser than the mantle below it. Think of it like an iceberg, but instead of floating, it's an un-iceberg that wants to sink. This instability creates what geologists call a lithospheric drip. A huge blob of rock, hundreds of kilometers wide, begins to peel away from the underside of the plate and sinks down into the deeper mantle. As it falls, the hotter, more fluid mantle material from below rushes up to fill the void. This explains the missing chunks on the seismic maps and the presence of unusually hot rock closer to the surface. This drip process isn't just a fascinating geological curiosity. It has dramatic consequences for us up here on the surface. When a massive blob of lithosphere detaches and sinks, it's like taking a huge weight off the plate above. The crust, suddenly lighter, rebounds upwards. This uplift can be significant, raising the land by hundreds or even thousands of feet over geological time. Scientists believe this is exactly what happened in the western United States. The incredible elevation of the Colorado Plateau, home to the Grand Canyon, has long been a puzzle. Mantle dripping provides a compelling explanation. The sinking of a massive drip beneath the region caused the entire landscape to be lifted upwards, allowing rivers like the Colorado to carve the magnificent canyons we see today. So, next time you see a picture of the Grand Canyon, remember that its grandeur might be thanks to a giant invisible blob of rock sinking into the Earth's fiery depths millions of years ago. It's a powerful reminder that the ground beneath our feet is far from static. It's a dynamic living system. But what does this process look like? Can we actually see it happening? Of course, we can't drill down there, but scientists have created incredible computer models to simulate mantle drips. They feed in data about rock density, temperature, and viscosity, and let the laws of physics play out over millions of virtual years. These simulations are mesmerizing. They show the slow formation of a dense blob, its gradual stretching downwards, and the final dramatic snap as it detaches and plunges into the deeper mantle. The models perfectly replicate the patterns we see in seismic tomography, showing the missing cold rock at the top and the upwelling of hot rock from below. Even more exciting is that we might be seeing the surface effects of an active drip happening right now. Areas like central Anatolia in Turkey are showing strange patterns of uplift and volcanic activity that do not fit traditional plate tectonic models. Some geologists argue that we are witnessing the surface expression of a lithospheric drip in progress. We are, in a sense, watching a new mountain range being born, not from plates crashing together, but from the mantle dripping away below. The implications of this discovery are huge. It forces us to rethink the fundamental engine of our planet. The simple conveyor belt of mantle convection is only part of the story. These drips represent a whole other mechanism for recycling crust and shaping continents. They can explain previously mysterious volcanic fields located far from the edges of tectonic plates, so-called intraplate volcanism. As the hot mantle material rushes up to fill the space left by the drip, it can melt as it nears the surface, creating magma that erupts as volcanoes. The volcanic plains of the Snake River in Idaho, for example, might be the trail left behind as the North American plate moved over a spot where a mantle drip occurred. It adds a whole new layer of complexity and beauty to our understanding of Earth. Our planet isn't just a set of rigid plates floating on a simple current. It's a dynamic, lumpy, and dripping system, constantly reshaping itself from the inside out. This research isn't just about satisfying geological curiosity. Understanding mantle drips has real-world applications. The upwelling of hot material associated with these drips can bring valuable mineral resources closer to the surface, guiding exploration for things like copper, silver, and gold. It also helps us better understand seismic hazards. While the drips themselves are slow, the changes in stress they cause in the crust above can influence the frequency and location of earthquakes. By mapping these hidden, deep earth processes, we can build more accurate models of geological risks and better prepare for the future. It is a testament to human ingenuity that we can piece together events that happened millions of years ago, hundreds of miles beneath our feet, using nothing but the faint echoes of earthquakes and the power of computational physics. So the next time you look at a mountain range or a vast plateau, remember the invisible world beneath. Remember the scorching ocean of rock, the slow, patient dance of convection, and the dramatic, world-shaping drips that peel away from the continents and sink into the abyss. The solid ground we rely on is just the surface expression of a far more turbulent and fascinating reality. The case of the missing mantle shows us that there are still profound mysteries hidden deep within our own planet, just waiting to be uncovered. Earth is constantly talking to us, through the shake of an earthquake, the shape of a canyon, and the heat from a volcano. We just have to learn how to listen. Thank you so much for joining me on this deep dive into the heart of our planet. If you found this journey as fascinating as I did, please hit that like button and subscribe for more adventures into the mysteries of science. And let me know in the comments. What other geological wonders would you like to explore? Thanks for watching and stay curious.